one of the applications of finding the first derivative, finding the second derivative is curve sketching. Curve sketching is fairly detailed, and there are certain steps. Once again, we'll give you a template that you need to go through when you sketch the curve. So it's not simply a matter of just putting a few points down and doing a rough sketch. You need to go through each and every one of these points when you're asked to sketch a curve, either in assessment work or when you're working through the tutorial. So what are the steps of this template? The first one is to look at the domain. The domain are the x values, and you should recognise if the function is defined for all points of x, from x is minus infinity to positive infinity. If it is not, you should make a note of certain values that x is not defined, the function is not defined for. So to actually note that x equals 3, for instance, the function does not exist, and to note those down. So we look at the whole domain, talk about the domain, whether the function actually is continuous over the complete from minus infinity to positive infinity. The second thing you should address when you're doing this, the second step of the template, is to find all intercepts. Now, we find the x-intercept by putting y equals 0 and solving, and we find the y-intercept by putting x equals 0 and solving. So we note those and note them clearly. Probably at this stage you should draw some x and y axes and start putting these values on your sketch. So whether you actually do it at the top or do it at the bottom, it doesn't matter. So you could actually start by actually drawing some axes and then do step 1 under that. But make sure when you do your sketch it's probably at least 5 or 6 lines high and right across the page. The trouble with starting with a blank piece of paper, that if it's you're not going to require any negative values for y or whatever, the function may be always above the x-axis, well, that's really not a big issue. So just draw yourself some axes right across the page, 5 or 6 lines, and start putting these points as we evaluate them. So that's the first 2 steps. Third step is to look at the symmetry of the curve. And symmetry, you can actually do that by actually looking at f of x and just negative x. Don't use values here, just put x and negative x. And if those two actually work out to be the same, then the graph will be symmetric about the y-axis. If f of negative x, once again, work out what f of negative x is. You've already done it up here, and you'll get a value. Then see if that is the same as just putting negative in front of the original graph. Well, it will be symmetric about the origin. So symmetry is the third step. The fourth step are to determine if there are any asymptotes. Not all graphs have asymptotes. And if you've got up here, you see that the graph is undefined for some x value, well, you should test for a possible vertical asymptote at that point. For instance, if you have y equals 1 on x, then the graph is not defined when x equals 0. So when you've got a fraction for the function, any value that makes the denominator equal 0, there's a good possibility that x value will be a vertical asymptote. So if f of x is not defined at x equals a, calculate the limit as x approaches a from the positive side. So here you do as x approaches 0 from the positive side. So how do you do that? You just let it equal a value a bit bigger than 0, 0.001, and see what the value of the function is. And then the limit as x approaches a from the negative side. So x approaches 0, so negative 0.001. And then you have a possible vertical asymptote at that point. And the other asymptotes can be horizontal asymptotes, and you do that by calculating the limit as x approaches infinity of the function and the limit as x approaches minus infinity for the function. And then that allows you to calculate whether you've got a possible horizontal asymptote. So asymptotes. And the fifth step is the sign of the gradient. and to get the sign of the gradient tells you whether the graph is rising or falling. If the graph has a negative gradient, how do you get the gradient? You find dy dx. And then if the graph has a negative gradient, then the graph is dropping. If it is a positive, obviously the function or the graph is rising. So that's the sign of the gradient, 5, and we do that by finding dy dx. 6 is to calculate all turning points, and we've already calculated dy dx, so find out where dy dx is equal to 0, find out whether they are maximum minimums, and find the corresponding y values as well. And 7 and 8, concavity. So we look at d2y dx2. So we're going to calculate that, and that will give us possible points of inflection. So when d2y dx equals 0, we have a possible POI, not a necessarily one. So then you would have to do the test to find out what's happening with the concavity with d2y dx2. If it's changing sign, we may have a point of inflection. And finally, you are to sketch the graph. So once again, if you are actually finding all these as you go, it's probably a good idea to start putting those points. So you need to label your graph, label your axes, put x and y on there, label your graph, whatever the function is, label all intercepts, so mark all those at appropriate spots, turning points, POIs, any asymptotes, and then finally a single line sketch for the graph. Don't start shading or whatever, just one single smooth line that will sketch going through all the points that you put on there. Okay, so that's the template, and the next little section there I'll actually go through and with a worked example and show you how to put that into practice.